Now let's learn about the copy on write array. Copy on write array is like having your own copy of book to read. When someone wants to write in the book, instead of disturbing your reading, they make a new copy. This way, you can keep on reading without any interruptions. You can use copy on write array when you have multiple threads accessing and modifying data at the same time. It ensures that readers don't get disturbed by writers, and writers don't interfere with each other, making your program safer and more efficient. Let's have a code demonstration which will tell us how we can use copy on write array in our Java code. We are in the concurrent collection. Let's create a class and let's call that as copy on write array demo. So what we are going to implement is two threads. One is the read task and the other one is the write task. And as the name suggests, that read task is going to read something and write task is going to write to something. And what it's going to read and write from is the copy on write array. So let's start the implementation. Let's create the read task. And this will implement a runnable interface. Let's implement the run method. And let's have a list of integers. Let's call this as list. The type would be integer. Let's name this object as list. And we can initialize this using a constructor. And what we want to do inside a while loop is we want to put some sort of sleep to the thread and then print the list. So that is going to mimic the infinite reading operation. So let's do that. So while true, let's call the thread.sleep and maybe it could be for 1 second. Let's do the exception handling. And once it's done sleeping, we will be printing the list. So that's about the read task. Now let's create the write task and it will implement a runnable. Let's implement the run method. And this as well is going to expect us to pass a integer. So let's do that. And let's have a random generator. And we could have a constructor. For the random, we could just say new.random. And in the run method, we are going to do two things infinitely. First is we will wait for certain time. Second is we will be writing certain value to the list. So let's do that. So let's have the while loop, while true, thread.sleep. Let's have this for 1200 milliseconds. Let's handle the exceptions. And outside the try catch block, let's call list.set random.next integer, and it's going to be in the size of list, and then random.nextInt, and the upper limit is going to be 10. So what we are doing essentially is that we have a list, and in that list we are picking any random index, and on that random index we are setting any random value that is in the range of 0 to 10. So that's about the write task. Now let's write another class that is going to mimic the simulation that we are trying to do. So let's call that as simulation. Let's have the list. Let's call this as private final list integer list, and let's create the constructor. So what we want to pass instead is new copy on write array list, and let's remove this one because this is not needed now. And to this list I want to add certain values. So arrays dot as list, and let's pass some zeros. Alright, so we have basically instantiated a list, made that as a type of copy on write array, and in that particular copy on write array we have provided some values which is all zeros. Now let's have a method, call that as simulate, and what this thing is going to do is it's going to create certain threads. So first could be new write task. Let's pass the list. Let's duplicate this. This one could be 2, this one could be 3, and this one could be 4. This as well could be a write task, this as well could be a write task, and let's have this one as a read task. So basically we have 3 writer task and 1 reader task. Finally, let's start these. 3.start, 4.start, and in the main class let's have the main method to begin with, and we will create the object for simulation, new simulation, and then let's call simulation.simulate. So let's go through the code once before we run this. So what we have done effectively is we have created 4 threads, 3 out of which are the writer threads and 1 is a reader thread. What the writer thread is going to do is it's going to run infinitely, and every 1.2 seconds it's going to set certain value in the list that we are going to provide, which is specifically the type of copy on write array. And the way it's going to write is it's going to pick any random index and going to place any random value. And what the read task thread is going to do is it's going to execute infinitely, it's going to run infinitely, and in every run it's going to sleep for 1 second and then print the list. And finally we are running all these threads, and this is basically we are creating the object and calling this simulate method, which is going to do all of these things. So now let's run this and see the output. So you could see that to begin with we have this array, then the writer thread wrote something, and then that is being read by the reader thread. So it keeps on happening that the writer thread will be writing something to the array that is pretty much random, and then the reader thread will be reading from the array. The point to note here is that this is being done in a multi-threaded context and we are not leading to any exceptions. For example, any modification exception or any kind of inconsistency. So situations like this, when we should have copy on write array list, and this particular data structure will help us in ensuring that an array list is being used in a multi-threaded environment without any of the synchronization or concurrency concerns. Now let's learn a few more things about the copy on write array. So now we will learn how it works. So when a thread wants to read from the array, it creates a snapshot of the array and uses the same to read. If a thread wants to write, it also creates a snapshot of the array and performs the write operation. Once the write is completed, the changed array is considered as the latest version of the array, from which snapshots could be created for the read and write operation. This way, readers don't see the changes until they get a new snapshot. It ensures that they always have a consistent view of the data. So we could loosely draw parallels between the Git branching approach and the way in which copy on write array works. Each modification to the array creates a new version, much like creating a new branch in the Git. Just as Git would allow for parallel development without conflicts, copy on write array allows for multiple threads to modify the data concurrently, and it does so without interfering with each other. And just as Git consolidates changes during the merging, copy on write array eventually consolidates the modifications into a single reference version. This version ensures data consistency. Both systems provide a structured approach to managing concurrent changes. So I think it would make sense to visualize what we just discussed. So let's do the same. So let's assume that this is our array and it has certain values as in 3, 5, 1, 2, and the first call on this array is a read call. Imagine this line to be the reference line and consider that this line has the latest value of the array. So whenever a read or a write operation is supposed to be done, those operations are going to create certain snapshots. So the first call that we are getting on this array is a read call. So as soon as we have a read call, a snapshot of this thing is created and the read will be performed on this one. So what effectively happens is that even though if there is any write operation that is going to happen, it won't impact this value because we have taken a snapshot of this particular array at this particular time. Since this line is the source of truth, during creating a snapshot, the same value remains to be seen here. And this is the array from which the read operation will be served. Now let's say going forward at this point of time, a write operation is invoked. What it says is that write a value 4 at index 2. So since this latest value or the reference value has this array that is 3512, a snapshot is created which is 3512, and on this snapshot the write operation is applied. So as soon as the write operation is applied, the array changes and the value becomes 3542, and the same value would be written to this source of truth or this line or this reference, right? So let's say we have a read operation now, and this read operation comes after the update has been written. So since this reference has this value of 3542, the read operation is again going to create a snapshot, and now the snapshot will contain this value 3542. So when the read operation is served, the same value is returned, that is 3542, and this process keeps on happening. So you see, what we have is our reference value to begin with and a line which is serving as a source of truth, and whenever we are going to have any read operation, we are creating a snapshot, and whenever we are having a write operation, we are creating a snapshot, and after that write operation is complete, then the same is merged back to the main line. So that is the reason I told that it is somewhat similar to the way in which Git branching works. So you could consider this as the master branch, and read is anyway read. It's not going to write anything or impact the data, but still we want to avoid a situation wherein the master branch could change during the read is being performed. So that is the reason a snapshot is being created to serve the read as well. But it's very evident that in the write scenario, another branch is created, and on that branch whatever writes are supposed to be done, those writes are done, the 4 in this case at index 2, and once this is done, once it is successful, the same thing is written back to the main line, to the main branch, and once this thing is merged, now the main branch has this particular value, that is 3542. So this is the way in which you could visualize the write on copy array, and I hope that it will help you in understanding this concept in a much better way.